Next is a farm that we call Natalie, and it's after my daughter. It's basically in a crater of a volcano. It's one of the most beautiful farms, probably the most beautiful farm I ever saw. So I named it after my daughter. And these are the separations of lots that this particular farm has. If you look over here, there's actually a riverbed that wraps around here. So the grounds here are definitely not going to be the same as the grounds over here, for example. So basically what we used to do when we would do soil analysis, we would take plugs of dirt, we would collect them, and we'd bring them to a laboratory. But what has happened is, through technology with our partners, we've come up with a new system at the time, which is basically a robot. And you screw that robot into the ground, and what it does, it takes all the particulars and it absorbs the ground in 107 days and pretends to be a tobacco plant. So it absorbs the ground, it comes up through a coupling, and actually we take a soil analysis of it. And this is the way it looks. I thought that was the most up-to-date and the most advanced thing I ever saw. And then we started working with a laboratory called Agristat out of Santiago, Chile. And what we did is we ended up doing some different stuff. Initially, what we did is we took all our imagery by satellite of all our different farms. And this particular farm is the Natalie farm. And you see here, we have it all sectioned off. So what happens with this system is, globally, the system takes 100-meter squares of each lot and then breaks them down. And what it gives us are what we call hotspots. And what we're doing is we're trying to even these colors out. So we want to know, do we have the right parts per million of nitrogen, potassium, phosphorus, and all its microelements to be adequate. Since this farm we developed it, a lot of the farm actually didn't need any fertilizer whatsoever. One of the problems we have, if you want to call it a problem, is the farm is actually too fertile. So the downside to that is, through erosion and through years, that hard pan, we're going to lose extra nutrients. The tobacco plant's only going to grab the nutrients it needs. So for example, if we need 6 parts per million of nitrogen, a lot of the farms have 13 and 14 and 15 parts per million. It's a good problem to have, because what happens is the tobacco plant's only going to absorb what it wants. So it's going to take these into little squares in 100 meters and then actually break this down all the way down into actually 8-inch squares. Together with our partners at Google, you can see that we have the imagery satellite now expanded into the farms. And then this is telling us all our hot spots of any devoidance of any nutrients the ground has. And you can see this farm is massive, and it really only has about a dozen hot spots in it. That's how nutrient rich the ground's here in Nicaragua. So once we do it, we bring it to a lab, and believe it or not, it's broken down into this 8-inch square, and each one of them are divisible by 5. So you're actually breaking the farms down into literally 3-inch squares. So what happens, we get the exact formula each and every time of fertilization, so we can grow this tobacco plant optimally. Why do we go through all the work with the seed? Why do we go through all the work with the grounds if we're not going to do everything right? So basically, this is a chart of the Natalie farm showing you potassium, nitrogen, calcium, phosphorus, boron, copper, and zinc. And what we're doing is it's going to tell us the spots, and each color is different. Not everyone has to be green or red. And these shows the optimum colors that each nutrient per lot needs to have. And then what we do is we basically add and we equal it out. Some of these farms are glowing because they're just so nutrient rich, which is a great thing. And then basically you have your points of lots where you have your hot spots, where you have your deficiencies at. So a lot of them are usually in the middle of the farm. If you look here, this one's in a corner, but each one of us tells any discrepancies or any types of hot spots that we need. It also tells us the texture of the ground, whether it's very mineral laden, whether it's more loamy, whether it has lime, whether it has more of a sand content. Same thing here tells us, and then what we do is we equal out these colors for the optimum amount for the tobacco growing. It tells us the percentages of sand and lime and so on. For example, this is a lot that has some sand content. You see it's very little sand content. The ground's here are volcanic, so we don't have much sand, and that's part of our secret of growing tobacco. And also the nitrogen that's disposable. If you can see how rich these grounds are, they're completely nitrogen rich. But this particular field right here needs a little more nitrogen, so we're going to add nitrogen to this little, it's actually about 1/4 of an acre that only needs it. What we're going to do is we're going to color code this, and we're going to even out this color so we have the right amount of nitrogen.